Okay, here's a quick video explaining my MYP1 algebra test. 7x plus 43 equals 85. I'd like to get the x bit on its own. I'm going to subtract 43 both sides to get 7x equals 42. And then I don't want to know what 7x's are. I want to know what 1x is on its own. So I'll divide everything by 7 and get x equals 6. Question 2. 9x minus 12 equals 42. I'd like to get the 9x bit on its own, so I'd like to get rid of the minus 12. I'm going to get rid of minus 12 by adding 12 to both sides. So adding 12 to both sides, I get 9x on its own equals 54. I don't want to know what 9x's are, I want to know what 1x is on its own, so I'll divide everything by 9, both sides, to get x equals 6. Question 3. 13 plus 4x equals 37. So I'd quite like to get the 4x bit on its own. So I'm going to take away 13 from both sides to get 4x on its own equals 24. I don't want to know what 4x's are. I want to know what a single x on its own is. So I'm going to divide everything by 4, and dividing everything by 4 both sides, x equals 6. On to question 4. Okay, so 31 minus 3x equals 10. Well, I don't much like the fact that the x bit is a minus, so I'm going to get around that by adding 3x to both sides. So I add 3x and the minus 3x disappears, but then I've got to add 3x to the other side as well. So adding 3x to both sides to get rid of the minus, 31 equals 10 plus 3x. Now I'd quite like that 3x bit to be on its own. So I want to get rid of the 10. So I'm going to take away 10 from both sides. There it is, minus 10 both sides, to get not 31 but 21 now equals 3x on its own. And I don't want to know what 3x's are. I want to know what a single x is, so I'm going to divide everything by 3, both sides, and then 7 is equal to x. So that's my final answer, x equals 7. Question 5. Now with fractions. X over 3 plus 12 equals 19. I'd quite like to get the bit with x on its own, so I'm going to take away the 12. Because it's like a balance, I need to take away 12 from both sides. So taking away 12 from both sides, I get the x over 3 bit on its own is equal to 7. But I don't want to know what x divided by 3 is. I want to know what a whole big fat hairy x is. So I'm going to multiply everything by 3 on both sides and get a whole x is 21. Question 6. X over 4 minus 8 equals 25. So I'd quite like to get the x over 4 bit on its own. So I'm going to add 8 to get rid of the minus 8. I've got to do that both sides because it's like a balance. So I get x over 4 equals, my goodness, that's a mistake, isn't it? That should say 33. I've forgotten to add the 8 to the other side. So that should say x over 4 equals 33, not 25. And then when I multiply, that's supposed to say by 4. I'm going to get 33 times 4 is 132. So that should actually say x equals 132. So how about that? Big mistake from me. Question 7. 7 plus x over 5 equals 26. I'm going to subtract 7 from both sides to get x over 5 equals 19. So that's to get the x bit on its own. But I don't want to know what x divided by 5 is. I want to know what a whole x is. So I'll multiply everything by 5 to get a whole x is 95. Question 8. 18 minus x over 6 equals 10. I'm going to add the x over 6 bit to both sides because I don't like the fact that it's a minus. So to get rid of a minus something, I'm going to add it to both sides and then it disappears, but I need to add it to the other side as well. So adding the x over 6 to both sides, I get 18 on its own equals the 10 that was there before plus x over 6. So that's helpful because we don't have any minuses to deal with now. I'd quite like to get that x over 6 bit on its own, so I'm going to take away the 10 from both sides. So taking away 10 from both sides, I get 8 is equal to x over 6, and then multiply everything by 6 to figure out what a whole x is. And then multiplying by 6 both sides, I get 48 is equal to a whole x. So that's my final answer, x equals 48. And then the final super challenging question 9. Challenging because it's got a fraction, a minus, and something multiplied by the x as well. So 26 minus 3x over 2 equals 8. I'm just going to add that 3x over 2 to both sides because I don't like the fact that it's a minus. So adding it to both sides makes it disappear on the left, but it pops up again as a plus on the right. Then I'm going to take away 8 from both sides to get the 3x over 2 bit on its own. Then I don't like the fraction, so I'm going to multiply everything by 2 to get a whole 3x is equal to 36. Then I don't want to know what 3x's are, I want to know what 1x is on its own. So dividing everything by 3, 12 is equal to x. There's my final answer, x equals 12.